Welcome to our final project video by Clara Weigel, Peyton, and MacDonald. We are table number 4.
To start with our introduction, global temperatures are rising, and there is an urgent need to understand how climate change impacts longevity. Research has shown that extreme temperatures can lead to dehydration, heart stroke, and other concerning conditions. Warm climates and industrialization can worsen air pollution. This can lead to respiratory and cardiovascular diseases. This project investigates whether life expectancy decreases in countries with hotter average climates. Our findings may help inform solutions to global warming and improve future outcomes for populations worldwide.
The question will be answered with an observational study using gathered data from online databases. The explanatory variable is the average temperature per country in 2024. 4 categories were created based on the range of temperatures in degrees Celsius. The classifications are as follows. Climate D is cold from -3 degrees Celsius to 5.499 degrees Celsius. Climate C is moderately cold from 5.5 degrees Celsius to 13.99 degrees Celsius. And climate B is moderately hot from 14 degrees Celsius to 22.499 degrees Celsius, and then finally climate A is hot from 22.5 degrees Celsius to 30 degrees Celsius. The response variable is the life expectancy at birth across the globe, and we had no control over the population sampled, and we expect that the data is a good representation of the citizens for the respective countries. Data accuracy is a major source of potential bias. Both data sets come from online databases with unclear collection and verification methods. Several confounding variables may affect our results, including climate data from 2024 versus life expectancy data from 2010 to 2020, wealth levels of each country, access to medical care, as well as causes of death within each population.
We chose an ANOVA test for the analysis of our data because there were more than 2 groups of data: a categorical variable, which was the climate classification of countries, and a quantitative variable, which was the average life expectancy in the countries. The ANOVA, null, and alternative hypotheses were developed as shown on screen. The null hypothesis is that the average life expectancy in all 188 countries of each climate classification would be the same, and the alternate hypothesis is that at least one of those means would be different. Prior to performing the ANOVA test, we had to check 3 different testing conditions. The first is randomness. We decided this condition was not met because the sample taken was not random and neither was the group assignment in the data. The second condition is the 10% condition. This condition is also not met because the number of countries used in the data is not 10% of the population. And finally, the data had to be normal. We also believe this condition was not met because it was not normally distributed and the central limit theorem was not met for all 4 climate classification groups. Although none of the condition tests were met in order to perform the ANOVA test, the education that we have got so far is not sufficient enough to be able to correct this issue. Instead, we performed the ANOVA test as is. On the screen, we see 2 different figures. In figure 1, there is a table of the number of countries in each of the climate categories on the far left of the table, as well as their mean average life expectancy and the standard deviation of that data. In figure 2, we see box plots separated by each climate category, showing the data of all 4 climate groups individually against an x-axis, which is the life expectancy. In total, we can see from figure 1, we had 188 countries in the data. Both figures tell us that climate categories C and D had significantly less groups in their data than in climate categories A and B, which could suggest that there are very few countries in the world with climates less than 14 degrees Celsius year-round. Also, another important piece of information to grasp from figure 2 specifically is that all of the climate categories have outliers in their groups. You can see these outliers based on the black solid squares toward the left end of the box and whisker plots. This could be evidence of poor group distribution of the countries into the climate categories. Since we chose an ANOVA test to analyze the data, an ANOVA table was calculated and is presented in figure 3. This shows the summary statistics of the ANOVA test, including the observed mean group difference calculated from the data. That other mean group difference number was then used to calculate the p-value using 1,000 random shuffles to increase the randomness of our data as well as the accuracy of the p-value, and that is shown in figure 4. Figure 4 tells us that the final calculated p-value is 0.0020. Since our calculated p-value from the ANOVA test is less than the significance level of 0.05, we have evidence to reject the null hypothesis. There's convincing evidence that the average life expectancy should be increased in countries with hotter average climates.
So in conclusion, our report aimed to answer the question, is life expectancy lower in countries with hotter climates? Data from 188 countries on climate and life expectancy was collected. An ANOVA test and p-value were used to analyze the data. The null hypothesis was rejected, showing convincing evidence that hotter climates are linked to a lower life expectancy. The findings are moderately valuable, but more research is needed. The study has biases and confounding variables which weaken the results. 14 countries had climate data but no life expectancy data, showing database inconsistencies. Future studies should cross-reference multiple databases for accuracy. And lastly, future research could also study other variables like wealth or education and their effect on life expectancy.
For our appendix, here is an image of all the data points put together. And then here is our works cited / references, and this also marks the end of our video. So thank you for watching.